So now we've finally come to doing a real stoichiometry reaction. So we've done balancing, we've done molar mass, we've done converting between moles and mass, and we've done ratio conversions. So this one here, so what you're going to get is a combination, but to start with, we're just going to do mass stoichiometry. So we're just going to have some sort of mass of A, and then we're going to convert it to the moles so that we can transfer it to B using the stoichiometric ratios, and then we grab the moles of B and convert that to mass. In the future, we'll have gas and solutions as well. So it's always the same. As long as I'm going from a mass to a mass, it's always the same thing. It's always this formula to start with. So converting that mass to a moles, and then at the end, I'll be converting that moles to a mass. So I'll be able to say, if I've got this much mass, I'll get this much mass, or if I want this much mass, I need this much mass, or whatever. Or if I have this much mass, I'll need this much mass to accompany it. So depending on what the two chemicals are. And so ratio conversions will get me tell me how much of the other thing I'll have in moles, and then I'll be able to do that third formula. So let's have a go at doing some of those. So the first one here, the balance, first of all, check that your equation's balanced. We have this one here, so we want to know the grams of oxygen, and we have this one here. So these are the two that we want to worry about. So the first thing we do is the number of moles is mass on molar mass, so do the labeled formula. You've got your mass from the equation here. You've worked out the molar mass as this. And so you've worked out what you're starting with is 1.5 moles of substance. So that's the first step. So always 3 steps. The second step is the ratio conversion. So from the balanced equation, you can see you've got 2 to 3, and you know you've got 1.5. So you do the 1.5 to x. So ratio conversions, you cross multiply, so 2x equals 3 times 1.5. So you know that if you have 1.5 moles of the first compound, you are going to end up with 2.25 moles of the second compound. So we've done first and second steps. Last step is step 3. So again, labeled formulas, substitute units, always the same formula, going from number of moles to mass. So we put that down there. The molar mass of oxygen is 32, and that's our final answer. 72 grams of oxygen. So if we have 184 grams of potassium chloride, I think it is, and then we'll get 72 grams of oxygen. Okay, so just doing that again. So this time, what are we doing? This time we are asking how many grams we need if we want 205 grams of this. So same deal. So to moles ratio, and then back from moles. So labeled formula, substitute units. So the mass is from the equation. The molar mass is from the periodic table, 2.75. It's a 2:2. So this is like a 1:1. You could skip this step this time. Instead of doing the cross-multiplying ratios, just say it's the same thing. That's the only time you're allowed to skip the cross-multiplying ratios, if they're exactly the same. You still need to put therefore it equals the same, and maybe put 2:2 therefore. You need to still make one statement, but you might not have to do the full working if it's exactly the same. All right, and then finally go from the moles to the mass. So again, labeled formula, and then substitute, and then units. So that's from the periodic table, and that's from there, and that's what you get. So if you wanted 205 grams of potassium chloride, you'd need to start with 337 grams. Okay, so do a lot of those practice questions. There are some on the website if you need more practice.